Hello and welcome. Today we're doing a question from LeetCode 75. It's called Asteroid Collision. We're going to jump right into it. We are given an array asteroids of integers representing asteroids in a row. For each asteroid, the absolute value represents its size and the sign represents its direction. Positive meaning right and negative meaning left. Each asteroid moves at the same speed. Find out the state of the asteroids after all collisions. If two asteroids meet, the smaller one will explode. If both are the same size, both will explode. And two asteroids moving in the same direction will never meet. So example 1, we have 5, 10, and -5. Both of these are moving to the right, but -5 moves to the left, which means there's going to be a collision between 10 and -5. Now, once these collide, the smaller absolute value, so 5, is going to explode, and we're just going to be left with 10 and 5 as our output. Example 2, we have 8 and -8. So 8 is moving to the right and -8 is moving to the left. Again, there's going to be a collision and they're both going to explode because they're both the same size. And we're going to be left with nothing. Example 3, we have 10, 2, and -5. So since this is moving right and this is moving left, they're going to collide and 2 is smaller than 5. So 2 explodes and we're left with the asteroid of -5 still moving left. Now, once this explodes, this is still moving left and this is still moving right. So they're going to collide 10 and -5, right? And here 5 would be smaller, so 5 is going to explode, and we're only going to be left with 10. Okay, like always, we're going to start off with examples. And I say this in almost every single video, but this step is really, really important. If you find yourself getting stuck or not getting the right answer, it's probably because you didn't spend enough time in this step. Because right now is where we're going to figure out our logic and work through examples and edge cases. If you yourself don't know how to solve this problem, it's going to be much harder to write code to solve it. You're not going to know what to write. Okay, say I have the following example, -4, 4, 6, -8, and 2. So I have 4, which is going to be moving to the left, then 4 to the right, 6 to the right, 8 to the left, and 2 to the right. So going asteroid at a time, the first one we come across is -4. There's nothing to the left of it, so it's not going to be colliding with anything. So we can actually keep a resulting array and just hold -4 in there. Now, the next asteroid we come across is 4, and it's moving to the right. So these are actually moving in opposite directions, right? But they're moving away from each other, so they're never going to collide. So 4 is also okay to keep. So we're going to have 4 over here. Now, the next asteroid is 6, also moving to the right. So no collisions are going to be happening, and we can just store 6 as well. Now we come across -8. This is moving to the left, so it's going to collide with its previous asteroid, 6. And what happens once these two collide? The smaller one will explode. 6 is the smallest one, so it's going to explode, which means it's now destroyed. So we have no 6 anymore. So say this is gone from here. These two are still on the path of collision. So 8 or -8, right, will still collide with the 4. And once these collide, 4 is smaller, so we're going to get rid of 4. Now we come across -4, and these are both moving to the left at the same speed, so there's going to be no collision, and we can actually keep -8. Now the last asteroid we come across is 2, and it's moving to the right. It's in the opposite direction as the previous asteroids, but it's moving away from those, right? So there's no collision or explosion needed. We're also going to have 2 at the end. So this is what our final array is going to look like. The only time there's ever going to be a collision is if one asteroid is moving toward the other, which means the first one needs to be moving right, and the second one, the later one we come across, has to be moving toward that older one, moving toward the left. Otherwise, any other direction, if they're both moving right, if they're both moving left, is okay, they're never going to collide. Or if they're both moving left and then right, is also okay because they're moving away from each other. So that's all we really need to do for this problem. Now that we sort of understand how we're going to be solving this, we can now go ahead and code this up. So to recap what we did, right, we moved through every single asteroid, and as long as there was no collision, so as long as the asteroid we were on was not moving to the left and the previous one moving to the right, we know there's no collision and we can just append that asteroid to this list we're maintaining. But if there is a collision, we're going to get rid of the smaller one, and we're going to keep checking all the previous asteroids to make sure there are no more collisions, stopping when we see an asteroid moving in the same direction or until there are no more elements in our list. Okay, to code this up, the first thing I'm going to do is initialize a stack, this resulting array that we're going to return at the end. So stack is going to start off as empty. Now we just want to loop through all of our asteroids. So for asteroid in our input asteroids, we want to see if there's a collision. And if there is, we're going to keep checking for more collisions. So while we still have elements in our stack, while it's not empty, this list, So while it's true and the last number we added is greater than 0, meaning it's moving to the right, so stack of -1 is greater than 0, and our own asteroid has a negative number, meaning it's moving to the left, so asteroid is less than 0, we know there's going to be a collision. So in this case, what we're going to do is pop off that last element from our stack. So last is going to equal stack.pop. And we want to see which element is bigger, the one we popped off or the asteroid we're working with. So if last is greater than negative of asteroid, we know our current asteroid is less than 0. So we're going to turn it into a positive by adding another negative. So double negative is going to make it a positive. So this way we can actually compare the absolute values. Now, if this last element we have is greater than the asteroid we have, we're not going to do anything. We're just going to append last back to the stack. We're not going to keep track of this asteroid because it's going to explode. So all we need to do here is to stack append last. And we're going to break out of this while loop. There's no point in continuing to go on here. We already checked that last element. It's bigger than our asteroid. Our own asteroid explodes, and there's no reason to keep going back in our stack. So we're going to break out of here. Now, there are going to be 3 scenarios in total if there's a collision, right? The last is greater than our asteroid in absolute value. It's equal to it or it's less than it. What are we going to do for every single scenario? If it's greater than it, we just add it back to stack. What if they're equal? So if last equals our asteroid, we're not going to be appending last back to our stack, and instead what we're doing is breaking out of this while loop because our own asteroid has exploded. So there's no reason to keep using that asteroid to check if there are more collisions down the line. Now for that last scenario, if last is less than our own asteroid, it's going to explode and we're not going to need to keep track of it. So since we've already popped it off, it's no longer in our final list, that stack. And what we're going to do is go back in this while loop and check the new last element in our stack against our own asteroid. So we do want to go back in our while loop in that scenario. So we're not going to break out for that, and we're not also going to append our last element back to stack. We don't really need to explicitly write anything out for that. Now, what happens once we're out of this while loop? Once we're out of this while loop, we want to take our own asteroid and just append it to our list. If there's no collision happening, right, we just want to keep track of it, adding it to the end of our stack. So if we're not going in this while, else, what we're going to do is stack.append our asteroid. And why are we doing this under an else? If you haven't seen this before, right, while and else, basically once we exit this while loop, we're going to be going in this statement over here, which in a regular while loop, right? Once we exit, we just go in the next lines anyways, but we want to take care of the scenario when we're breaking out of our loop. If there's a break in a while loop, it's going to break out of this entire while else, so we'll never append that asteroid to our stack, which is what we want, right? If that last asteroid is bigger than our own, we don't want to keep track of it, so we don't want to append it to our stack. And if they're equal, again, we don't want to append it to our stack. So because of these breaks, we're going to put this in an else. And we're going to see this once we do an example as well. So once we're out of this entire for loop, all we have to do is return our list. So we're going to return stack. So this is our code. Let's go ahead and submit this. We're getting the wrong answer for 8 and -8. Let's see. This should have been negative asteroid. So now we're actually comparing the absolute values. Now we can go ahead and submit this. And it is accepted. Now before leaving, we're going to do a complete walkthrough of our code line by line with an example to make sure we truly understand exactly what's happening. I have the following input asteroids over here. This is my example. The first thing I want to do is initialize an empty stack. And now I just want to loop through all of my asteroids. So I'm going to start off with 16 over here. And we're going to check this while condition. While stack, immediately this is not true. Stack is empty, so we don't go in this while. Instead, we go in this else and just append our own asteroid to the stack. So we have 16 and we go back into the for loop. So our new asteroid is 8 and we're making the same checks while stack. This is now true. And the last element of stack is greater than 0, also true. And our own element is less than 0. That's not true. We're 8, which is greater than 0. So we exit out of this while condition and go in this else, appending our own asteroid to the stack. Going back in the for loop, again, we make the same check. Stack is true, last element's greater than 0, but our own element's also greater than 0. So all we do is append that element to our stack. We go back in our for loop, and now we're going to be checking this, right? Stack is true, the last element's greater than 0, and our own element now is less than 0, which means there is going to be a collision. Now, what do we do in that case? We're going to pop off the last element from our stack and store it in a variable called last. So we get rid of this one, and we store it in last over here. Now we want to make a check. If last is greater than the negative of our asteroid. So our asteroid is -8. Is 1 greater than -8, so +8? 1 is not greater than 8, so we don't go in this if condition, we go in this elif. Is last equal to negative asteroid? That's also not true, right? 1 is not equal to 8. So we don't go in this condition either, and we just go back in our while loop. Basically, what we've done is just removed that smaller asteroid and destroyed it. So now we're back in this while loop, right? While stack, that's true. And the last element of stack is greater than 0. That's also true. And our asteroid, which is still currently -8, is less than 0. There's going to be a collision, and we're going to store that last element in our stack. So we popped it off, which means last is now going to hold 8. We check, is last greater than negative of -8? 8 is not greater than 8, so we don't go in this if, and we go in this elif, right? 8 is equal to 8, so all we're going to do is break out of this while loop, which means we're not going in this else, we break out of this while else entirely. And this is because we don't want to be appending that -8 to our stack. -8 collided with 8, and they both have exploded. So all we're doing is going back in our for loop. So our new asteroid is going to be 3, and we check while stack, and the last element of stack is greater than 0, and our own is less than 0. That's not true, so we don't go in this while, we go in this else, and we append 3 to our stack. Going back in this for loop for the final time, while stack is true and stack of -1 is greater than 0, and our own asteroid is less than 0, there's a collision happening. We pop off from stack. Last is now going to hold 3, and we check if last greater than 2. That is true, so we're going to be appending to stack that last. So we append to stack 3 over here, and we break out of this while loop. So we break out of this entire while else, which means we're not going to be appending -2 to our stack. And that makes sense, right? -2 and 3 have collided. 2 was smaller, so we're going to not keep track of it. It's exploded, it's gone. But 3 was bigger, so that gets to stay. And once we're out of this for loop, since there are no more elements for us to iterate over, all we do is return our stack, which is 16 and 3. And intuitively, this makes sense, right? Because these two asteroids will collide first, and 1 explodes, so we get rid of it. Then 8 and -8 both explode. Then 3 and -2 is smaller, so it explodes. And because of that, there's also no reason to go back in the while loop and continue making checks. It exploded and it's gone, which means we're left with 16 and 3, which is what we would output. Now, talking about space and time complexity. For space, our stack could potentially hold as many asteroids in our input. So this is going to be O of n, right? They could all just potentially be held in that stack. And for time, we do loop through everything in asteroids. So this is again going to be O of n for both space and time. Now, we just did a full walkthrough with an example, but if you have any questions, of course, let me know down below. I will answer all of them. If this video was helpful, like, comment, share, and subscribe. It really supports the channel. And as always, I will see you in the next video.